So we have part of object inside water, now this is equal to volume, okay, volume of displaced water divided by volume of object. Now let's give a symbol, so that will be, so volume of displaced water, I'll write it VW. So volume of object, let's write it VO. Okay, now let's go from the law of flotation. From law of flotation, okay, from law of flotation, now we have, okay, so what we have from there, so weight of object body, no problem, this must be equal to weight of water displaced. Now weight of water displaced, so this is equal to, so weight formula we have m into z, I'm writing here all, so this is equal to m into z, so this is body object O, water W, G and G, let's cancel out, so or mass of object, again in terms of density and volume we can write here d into v, so this will be again d into v, so we have over here density of object, volume of object, density of water, volume of displaced water. Or now we have to see that, so I need part of object inside water, and that is VW divided by V naught, or V object. Okay, so if you see VW is over here, V naught is over here, if you bring this it will be divided. So let's take this, okay, you will get, or D naught divided by DW is equal to VW divided by V naught, and this is the part of object inside water. Or you can say D naught divided by dW is equals to part of object, object inside water. So we can use this formula, but I'll advise don't use the formula directly. Okay, d naught divided by density of object divided density of displaced water. If you do this, the answer will come in one line. Okay, it's very short, and I don't think it will consider, examiner will not consider this a good view. So we have to do this all and put the value over there, so it will be easy. Now let's do some question, and before that I want to point out one more formula. Okay, now the last one formula is part of object, part of object outside water. Now this will be equal to, so part means ratio, now we take 1 as a whole, so this will be 1 minus part inside. So part inside we have already calculated from the above formula, and we can also find the part outside. Okay, here we have a numerical problem. So it states that when an ice block 50 cm into 30 cm into 20 cm is placed in water, what portion of ice should be outside of water? So we are given density of ice and density of water. Now whenever you do the numerical, I'll always advise you just underline the number, and it will give you idea. So 50 cm into 30 cm into 20 cm. So what are we given this? So these are the dimension of ice block, length into breadth into height. This always follow this pattern, L into B into H. So L into B into H, that means the volume. If you multiply these three things, we get volume of ice. Now next thing we are given, density of ice is given 0.9 gram per cm cube, and density of water is also given 1 gram per cm cube. And let me give you one more suggestion, advice, that see, if you see over here, all the unit their expression CGS system. Now it's not necessary that you convert them into the SI system. Okay, if all are given CGS system, you do this, and at the last when your answer comes, you can convert that into SI unit. That will be much easier thing to do. Okay, now we have to find the what the question says, what portion of ice should be outside so we are asked to find part outside, and we know that. So part outside, so see let's talk about thinking mechanism. Now when you try to solve the problem, we always have thinking mechanism, you know, there are certain ways. So what's our mechanism? So if we talk about the mechanism, so we see we have to find over here part, okay, we have to find part outside, we have to find part outside. Now we know part outside is equals to 1 minus part inside. So first we have to find the part inside. Again, we know the formula of part inside. So what should we do? So part inside is equals to volume of displaced water divided by volume of object. So volume of displaced water divided by volume of object. So to do this, we know that what we have to apply, so we should apply law of flotation. Okay, so that means we have to start from the law of flotation. We have to find part inside, and once we find part inside, then we can find part outside. So then let's begin it. So say I'm not going to write the given information, you can do it yourself definitely. So I'm just starting with the main idea. So I'll start here from law of flotation. Okay, okay, I can also write it over here. Now we have, now generally it's better, you know, if like write like this, because here weight of body, okay, sorry, in our question the body is ice, so I'll write it over here ice. Weight of ice is equals to weight of displaced water. Now this concept, this is the central idea of law of flotation, and it's better, you know, to write law of flotation, you know, sunma sugandhasto, it's much better. So now let's write, or we have, now we know the formula of weight, that is m into z. So weight formula m into z, so z and z cancel out. For ice I'm writing here I, for water let's write w, or we have here d into v, over here d into v. So ice I, this is I, this is water w, and we know that the formula of part inside is vw divided by v naught. So in this case that will be vi, or you can write that will be vw divided by vi is equals to di divided by dw. So I don't have a space over here, so what I'll do, I'll turn the page. Okay, so we have di divided by dw equals to vw divided by vi. So density of ice, okay, it's given, that is 0.9 gram per cm cube. Similarly density of water, that is 1 gram per cm cube. Now in the place of vw divided by vi, I can write over here part of ice inside water. Okay, and you know, it's better if you write a region like that. It shows, you know, since part inside is equals to vw, in language you can write, but I'm just writing over here in shortcut vw divided by vi. So that is, or we have part inside. Okay, so I'm just writing over here part inside is equals to, that is 0.9. so we have to write in terms of fraction, so this will be 9 divided by 10. Now we have to find part outside. So part outside, okay, so part outside is equals to 1 minus, so this is 1 minus part inside, 1 minus part inside, so this will be 1 minus 9 by 10. If you take the LCM, so this will be 1 by 10.